All right, guys. So here's the deal. You've just done your activity on Avi and Benita, and you can see that based how they made money, definitely a big difference. One started out very consistent, went up $100 every time, versus Benita. She is growing exponentially. So you can see there's a big difference between those two. And we're going to kind of dive a little deeper into this today. And I want to kind of do a side by side comparison for you guys. So grab your notes. You're just going to write down exactly what I write down and listen along as well. All right. So what we're trying to do is we're trying to do a comparison of a linear form versus an exponential form. All right. So there's linear models and there are exponential models. They're very, very different. They have some similar letters, but I don't want you to get them confused. So the best way we can do this is to look at them at the same time. So first things first, you actually know the linear form very, very well. Y equals mx plus b. So we've spent a lot of time working on that. You've worked on a lot of middle school as well. That's your linear model. Y equals mx plus b. Hopefully you're remembering that the m is your slope and the b is your y-intercept, okay? So let's write that down right here as well. You have m in here. Your m is your slope, your constant rate of change. And then you have the b value here, and the b value was your y-intercept, okay? Kind of like your starting amount, what you started out with. All right. Now, the exponential model is very different than that. Very, very different than that. So, the way that the exponential model works is we still have y equals, but now we're going to start with what we call the letter A. All right. The letter A. We multiply the letter A times the letter B. And you might be thinking, oh, I already know what B is. Well, hold your horses. That's not the same B. And then instead of having x on the same level like we do here as everything else, this is called exponential because the variable x is now your exponent. So it's so important that you now see that the variable isn't on the same level as everybody else. Your variable x is now the exponent of the function. So once again, we have two separate letters here. We have A and we have B. Now I'm going to stress this very carefully. Obviously, you can't get the A confused because that's not in the linear model, but the A in the exponential model is also kind of considered your starting amount, where you're starting from. Okay. Sometimes it's the y-intercept, but it's not always the y-intercept. So you've got to be kind of careful there. Your A is the starting amount. Then the B, and let me say this very carefully. These two right here, these B's are not the same. They are not the same thing. So I know that they're the same letter, but they are not the same B. Okay, they represent very, 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 very different things. So please be careful with that. That the B value in linear is not the same as the B value in exponential. Okay, so what is the b value in exponential? The b value in exponential is basically what we call the rate of growth, or our growth rate. Our growth rate. Okay, so have you ever heard someone saying, hey, the money is doubling or the population is doubling? That word doubling or tripling or quadrupling, really what they're talking about there is their growth rate. That's their rate of growth. Okay, so let's look at two different examples, two separate equations, and we're going to see kind of how they play out and work together. First one, we're pretty used to that. Let's just say we have 3x plus 2. Very basic equation. Okay, our second equation, why don't we say we have y equals our a value? I'll make it really simple on us for later reasons. I'm just going to leave it as a 1. Our b value I'm going to use as a 2, all raised to the x power. So you can see that how these equations are very different from one another, and you want to just be careful on how they interact. So the first way that we're going to look at how they're different is by looking at their tables. Okay, so you got this all in one page. I'm going to have to rewrite my equation here. So my first equation is y equals 3x plus 2, and y equals 1 times 2 to the x. So let's go ahead and plug in some tables. So the way we're going to do this is we're going to go ahead and just do 0, 1, 2, 3, and 4. Same thing right here, 0, 1, 2, 3, and 4. So go ahead and copy those in. And then once you've copied those, then we're going to start to figure out what are the y values. What are our y values for each of these? So the y values are if we plug this in. So here I'm going to just show you what I'm doing. 3 times 0 plus 2. 3 times 0 plus 2. This would be 3 times 1 plus 2, right? So if we plug those in, let's simplify here. 3 times 0 is 0. 0 plus 2 is 2. Here, 3 times 1 is 3. 3 plus 2 is 5. And hopefully you can kind of start to see the pattern. My next one is going to be 8. My next one is going to be 11. And my last one is going to be 14. So that's what's happening. As we plug those in, we're going to get our y values. Okay. Take a second to finish that table if you need to. Now, what about the exponential form? So exponential form, if we plugged in, we'd have 1 times 2 to the 0. 1 times 2 to the 0. Well, you can see that 2 to the 0, we've already talked about that, that's just 1. So 1 times 1 is 2, is 1. There you go. 1 times 1 is 1. Okay, let's plug in positive 1. So 1 times 2 to the 1, well, 2 to the 1 is 2. 2 times 1 is 2. Plug in 2 to the 2. 2 to 2 is 4. 4 times 1 is 4. 1 times 2 to the 3. 2 to the third is 8. 8 times 1 is 8. 1 times 2 to the fourth, that is going to end up giving me 16. Okay, so let's go ahead, before we do a comparison of these two, let's go ahead and graph them. Let's go ahead and graph these two, both these functions, okay? So if we graph these, all right, my first one is going to be at 0, 2, so 0, comma 2, then 2, 1, comma 5, then 2, comma 8, and then we're not really going to be able to fit anymore. 3, comma 11 would have been up there. So you can see what type of equation is that making. It's definitely drawing a straight line. And it should be because it's a linear function. This is a linear function. So it's definitely creating a straight line. Now this one's going to be the one that's a bit more interesting. Let's see what happens when we graph these points. Our first one is 0, 1. So we got 0 and 1. That's 0, 1. Now 1 and 2. So 1 and 2. So I'll go over to 1 and up to 2. Now 2, 4 up here. 3 up to 8. Okay, and then we can't even fit the last one. So notice what this is doing. I'm going to kind of help you out here. I'm going to tell you that this actually is completely flat right here, and it's not going to go lower than that. And then all of a sudden, just like it did in the Bonita and Avi example, it starts to grow really, really quickly. It starts to get really, really big very, very quickly. That it exponentially goes upward. So we really want to do a deep dive comparison between these two things and see how they really start to interact with each other. So the real most important comparisons I'm going to talk about in the next video. So move on to the next video here, and we're going to see how these compare with one another.